Hello, welcome to Enlightning.
Well,
Today we're
thank you.
starting.
Glad to be here.
Yeah, so glad to have you, Finn. Flynn. Today we're starting a series on service mesh. Is service mesh I? What's the plural? Service meshes,
We usually go
and
with meshes, but I don't know.
a murder of services, whatever. So we have Flynn here. So,
A murder of meshes. I'm gonna use that. That's a good one.
murder.
Yeah.
So happy that you're here, Flynn. Tell us about yourself.
I'm happy to be here as well. I'm Flynn. I'm with Buoyant. I'm a technical evangelist, which is easily the funniest job title I've ever had. Um, so my job these days is to go and dig into things and tease apart how they work, and then teach them to people, which is kind of fun. Uh,
Yeah.
Before that, I've been in computing for 4 decades, 40 years, not 4 years. That's kind of terrifying every time I think about it. Um, I was the original author of Emissary Ingress before coming over to Buoyant, and I tended to spend a while trying to figure out how to do things that work effectively without having to be as complex as we tend to assume that they are. So
I
yeah,
love it.
that brought me to Linkerd.
Awesome. One thing
Yeah.
I like about covering Linkerd first in the series is I understand that Linkerd what is the first service mesh of the
Yeah.
ones still around at least. Yeah, is that correct?
Linkerd is actually the one that coined the term service mesh,
Ah,
and is also the first graduated one. These days, Istio has also graduated.
cool,
Um,
cool. Yeah, that's
yeah,
pretty recent.
but
Yeah.
yeah, Linkerd actually, I think, was the fifth CNCF project overall.
Oh,
Um,
whoa.
yeah, we've been around a little while, actually. It's also kind of cool, right? Yeah.
I want to say hi to some folks in the chat. Napalm Codes is
Hi,
here.
folks in the chat.
Hello, folks in the chat. What's up? What's up? Good to see you. Napalm, it's been a while. Findle, it's been a while. Hello, friends. It's been a bit and a half. I hope everyone's doing so well. Yes, so well. We're
Yes, indeed.
talking KubeCon soon. Will I see you at KubeCon, Flynn?
You will.
Yeah? Will
Um,
you?
well,
Yeah.
you'll see me at KubeCon unless you decide to run away, which sometimes people do.
I'll see you. I might not talk to you.
Yeah, exactly. I hope you'll talk to me though. I mean, it was nice to meet you in Amsterdam, and
Yeah,
so
yeah.
hopefully we'll get to chat again
I,
in
I,
Chicago. Paris isn't quite yet.
when I see you, I'll run towards you, not away.
Oh, good. Glad to hear that.
We have Avo here. Avo says hi, Flynn. Hi, Whitney. Hello, Avo.
Hi, Avo. Avo.
Um,
Avo.
yeah. So for those people who haven't been to a KubeCon, what do you look forward to when you start? I have so many questions. How many KubeCons have you been to? So if you've been
Oh
around,
God, I don't even
yeah,
remember. Um,
yeah. Do you still get excited, or are you just like, another day, another KubeCon?
Kind of another day.
Yeah.
I don't even remember how many I've spoken at actually.
Yeah.
Um, I think I started going in like 2018, maybe. Um,
Okay. Okay.
but of course, didn't go in 2020 or 2021, I guess. But um, people who have not been to them, I think, well, first I would point out that something like 60% of the audience at every KubeCon, that's their first KubeCon.
Yeah.
So there's always a bunch of new people. So if you have an interest in going, I would encourage you to do that.
And I heard the one coming up in Chicago is forecasted to sell out. It's at like
Uh,
9,000 right now.
yeah, that's happened, I think, for a little while, for the last
Mm-hmm.
few KubeCons. Um, I would definitely encourage people to go wander around the project pavilions, as well as
Yeah.
the project pavilions are the booths for CNCF projects, purely open source stuff, as opposed to the vendor booths, which are usually companies who want to sell you something.
Yeah.
Um, so it can be very interesting to wander around the project pavilions, and you will often get a little bit more of an opportunity to talk to some of the project maintainers and get into some more of the technical stuff there. Um,
Yeah. Or if you
I've
hear about a project
yeah
you really like in like a talk and you want to learn more, like a great
yeah
next step is to go talk to someone at that project in the project pavilion. Although there's something like 170 CNCF projects now, so not all of those are in project pavilion.
you have to
But
sign up for the pavilions, and I think you might have to be incubating. I don't think sandbox projects get
okay.
to have a booth there, but um, one of the big wins of KubeCon that people don't talk about very much is
Hmm.
that you actually get to meet and interact with humans who are behind these projects.
Yeah.
And if you are at all interested in contributing to a project or helping out with a project, knowing the humans behind it is a huge win. Um,
Yes.
I mean, in general, I tend to think it's a good idea to interact with humans as opposed to just look at dots on a computer screen like we're doing right now. Napalm says Napalm Codes thought it was all Skynet AI.
Not yet.
See, this
Just a
this
matter of
is the
time.
mindset that worries me. Yeah, the hallway track. Uh,
Yeah.
okay, I have a confession to make. When I am at KubeCon, I almost exclusively do the hallway track. It's it's so much more valuable to me than a bunch of the other things that I will often just go and watch the talks, the
Yeah.
recorded stuff afterwards, unless there's one that's really, really interesting to me.
I
Um,
very rarely go to a talk, but I will like make a sketch, make like the app that's called Sketch. I'll make one, and then the videos when they come out populate to the sketch, so I can
right, which is great.
organize myself that way.
Yeah,
Hmm.
yeah. There's a lot of value in just meeting people, talking to people,
Hmm.
reestablishing contact, that sort of thing. Yeah.
Yeah. And knowing the people behind the project, you can, first of all, it's less scary to interact with them online later. I
Oh
don't know
yeah.
why I get so scared, but I do, or have in the past, we'll say. Maybe not so much
Oh, I
anymore.
don't understand why. It's not like anybody on the internet is just a jerk to other people or anything, especially not to women. That never happens.
That is pretty unreasonable of me.
Yeah.
But also
This is
then
why we
like
can't have nice things, you know? But yeah, meeting the humans is great and helps a lot with that.
Napalm's like the internet's so wholesome. It is. It's all
Oh yeah,
sunshine
it's
and
the most
rainbows.
wholesome place on the planet, right after Disneyland.
Yeah, that's really wholesome too. Anyway, but then like also when if you want to get involved with a project and you don't know where to start, it's really helpful to have a conversation with someone.
Yeah.
There are like projects will make like good first issues or something, but to have a conversation about what your skills are and how they fit in is a lot more
Mhm.
comfortable for me than trying to guess. Oh, we have so many friends here. Hello, good to see you. Cormaj is the
It is.
best. Cormaj always asks really good questions. Um,
Uh-oh. I mean, great.
that is
Um,
my line. Okay.
uh, I was also
You're
going to
asking
point
for a
out
lot.
with respect to contributing,
Uh huh.
probably also worth noting that contributing via code is only one way of contributing. And
Yeah.
like one of the really great ways to contribute to a project is actually just to write docs or to
Oh.
to go through and give feedback about what you found worked really well or did not, things like that. So there are a lot of ways to contribute that don't involve writing code if code is not your skill set, and some of those ways are arguably more valuable than trying to contribute code.
Absolutely. That's always a great point. So, how napalmed is my microphone better? Thank you for great. Thank you
It's
so much for
definitely
pointing
louder
that out.
here. Yeah.
Yeah. Sometimes I think I think I talk maybe at a normal volume, but I laugh really loudly, and I think the
Yeah,
algorithm
that
makes my
doesn't sound at
speaking.
all familiar.
Okay, so let's get down to business here. I'm gonna start scooting behind the light board, but before I do, I have lots of links to drop in the chat. Well, chat, y'all. Who of among y'all has worked with Service Mesh before? Who's looking to maybe implement it? If you are using it, which Service Mesh did you choose and why? Tell me about your Service
Your
Mesh.
service mesh experience.
Yes. And then meanwhile, I'm going to put a bunch of some links in the chat, and Flynn's going to explain what they are.
Okay. So www.linkerd.io is the Linkerd project itself. That's a great, yes, Thindle, you should definitely be ashamed if your answer is no, you're not using a service mesh. We'll talk about that.
If we could see your face, I would tell you to hide your face.
Yeah, we will. In all seriousness, we will talk about some of that stuff, right? So, Linkerd.io is the Linkerd project itself. That is a great place to go to learn about Linkerd and poke around and get some information about stuff like that. Buoyant.io is the place where I work. That's the company that created Linkerd. It's also a good place to go to find out some more about the commercial side of Linkerd, if that's your thing. Let's see. Buoyant.io/SMA. I think I'm out of sync here. Buoyant.io/SMA is Buoyant's Service Mesh Academy. We run that every month. That is a live stream where usually me, but sometimes other folks as well, digs into some of the technology and tries to explain how things work and answer questions and all that. The next one coming up is on, I want to say October 27th with Regina Scott of Argo CD. So we're going to be talking about using Argo and Linkerd together. And the last one that I skipped over was KubeCrash.io. KubeCrash is a free virtual conference that happens before KubeCon. This year it's, I want to say October 17th, where we will be talking about multi-cluster at scale using only open source projects.
Ooh. Wait, is that an in-person?
That is virtual. That's virtual only.
Okay.
Yeah, it's free. Cool. It's virtual. You can sign up at KubeCrash.io. It should be a lot of fun, and hopefully you will watch us showing off how everything works really well. If not, you'll watch us showing off how things can go wrong and you try to fix them on the fly. So it should be a good time, right?
It'll be entertaining either way.
Yeah, quite entertaining either way. If I scroll back a little bit, Napalm Code says he explored ECS service mesh, and then went in on no employer has gone in on Kubernetes. That's, one of the things that I think the Kubernetes crowd forgets a lot is that there are a lot of people out there who are not yet using Kubernetes. And so we should probably be figuring out a little bit better how to explain Kubernetes to folks. The Kube ecosystem has a lot of really, really good reference docs for people who are already experts, and not a lot of really good docs about how to become an expert if you're not already an expert.
Yeah.
Ebosep says, just looking and learning. Oh, you're in the right place. Great. Thindle says, it's even worse. What's a service mesh? We are actually going to talk about that. And that is a much, much more common question than people might think. Yeah, Mate. Okay, so Mate is definitely biased because he is one of the Linkerd maintainers. Thank you for your work there, Mate. And I'm kind of glad to hear that he would pick Linkerd, because it would be really depressing if we had any maintainers who would not pick Linkerd. Yeah, 100%. Yeah. So yeah, I guess while you're getting started, I can talk a little bit about what a mesh is, and then we get to watch Whitney frantically catch up trying to write things on the whiteboard.
Oh, no.
No, actually, meshes themselves are not, they're one of those things where the concept is fairly simple, and then the devil is in the details, and there are a lot of details. The concept here is a service mesh is a layer of infrastructure that adds security, reliability, and observability underneath your application uniformly across the entire application, so that your app developers don't have to worry about constantly re-implementing all of these things. So, okay, we'll let Whitney write for a little bit.
Is service mesh, is it always Kubernetes?
No.
Okay.
Linkerd at the moment focuses on Kubernetes, but the concept applies very much outside of Kubernetes. And in fact, one of the questions that we get at Linkerd a lot is, okay, great, how do we extend Linkerd so that it can interact directly with VMs and such, not just Kubernetes containers? And the answer to that question is, up through Linkerd 2.14, you're stuck with Kubernetes. but come talk to us a little bit later. Um,
We're working on it. Okay,
yeah,
so it's a layer.
it's an
Will you
infrastructure
repeat it?
layer. Yeah, an
Okay.
infrastructure layer that adds security, reliability, and observability uniformly across your whole application.
And security
Reliability
and observability
and observability.
uniformly.
Yep.
Across your entire application.
Yep.
I've never thought of service mesh as being application specific before.
Well, it's not specific. Like, there's no such thing as Linkerd for a single page web app or Linkerd for accounting or something like that, right?
Uh-huh.
But without an application, what's the point?
Yeah.
Right?
What's the point of
This,
any of this?
and you laugh, but this is something where I kind of wonder sometimes about how often that is missed. Nobody runs Kubernetes just to say that they're running Kubernetes. That is
Yeah.
not the point. People run Kubernetes so they can accomplish something. The
Uh-huh.
humans using the cluster have some goal that they want to accomplish.
Yeah.
And to the extent that we are doing things that are not in service of meeting that goal, we're getting it
Uh-huh.
wrong.
Yeah.
So the only really relevant way to think about a service mesh or an Ingress controller or a cluster or a CNI is in service of letting the users of the cluster accomplish what they need to accomplish. So starting by thinking about the application is really important. And no, I'm not at all bitter that some of this feels like it's fallen by the wayside. Why do you ask? This isn't something I think about ever. Yeah.
Things have been made harder than what they need to be. I want to say hi to
At
Feel Snobble. Feel Snobble's here. We have so many good friends today. That's very happy. Yay.
at Kubernetes Community Days in Guatemala not too long ago, I actually did a talk titled Kubernetes para humanos, Kubernetes for humans. And yeah, I might see about trying to bring that to KubeCon later. Not sure.
Nice. Napalm Code says, I mean, ultimately, service structure layer that keeps you from having to build certain reliability concerns, etc., into your app directly.
Yes. And one of the things that's really interesting about this is if you look at those three things, security, reliability, and observability, none of those are optional. Nobody working on an application is ever going to say, oh, yeah, we don't need reliability. That's cool. The only one that you occasionally need to argue a little bit about is observability, because there really are a lot of developers who don't understand the need for observability in a broad, uniform sort of way. But yeah, all of these, if you do not use a mesh to add them, your developers have to add them to every individual microservice that's part of your application. And the reality is that as you go through and you do that, what you're going to find is that some of your developers will get it wrong, and many of them will not do it in the same way as many of the others. Just that's not trying to diss the developers. That's just human nature, right? So that can end up being expensive and complex if you don't do it below your application. If your service mesh does this correctly, you don't have to modify the application at all.
Yes.
Thindle notes if the application is totally crashed, it is safe and reliably offline. You're right, but
and
also if it's totally crashed, it's probably pretty reasonable to assume that you can observe that it's crashed. So maybe you get 3 out of 3, right? It's not what we're after. Not what we're after at all.
Kormaju's bringing it with the good questions already. What's the difference between service mesh and service proxy?
That's a lovely question. I'm going to guess that Koromaju maybe just filled out the CNCF survey that had a question about this on there. And
yeah,
Yeah, technically service meshes always include service proxies by any definition I can think of. So I'm honestly kind of unsure about that. To me, a service mesh feels like what you get if you have a bunch of service proxies that all act together and that all have a single control plane that is running all of them so that they can be working together. Not actually sure what the CNCF was going for with that question, though. So it'll be kind of fun to talk to some of them at KubeCon and ask them, guys,
How would you define a service proxy?
anything that sits in between two services and relays traffic while also adding some other functionality.
Okay.
So you could do a service proxy whose purpose in life was to retry things if it goes wrong. You could do a service proxy whose purpose in life is to do MTLS in between services. But, a mesh is kind of what you get if you group a bunch of those together and control it in a uniform is not quite the wrong word here.
Centralized.
In a centralized, single, consistent way.
Yeah.
Centralized is kind of a dirty word in Kubernetes, but you really do want centralized control in the sense of, you would like it to be the case that somebody can sit down and go, this is the way my mesh is going to operate. You want that. You want the control plane to be distributed for reliability, and so you don't have single points of failure, but centralizing the ability to control things is usually very useful.
Yes. We have Napalm has a comment. Napalm ultimately thinks the infrastructure layer lets us focus more on business logic concerns and iterate quickly, which was the promise of microservices.
Yep.
Napalm would argue that a lot of microservices reinvent the same, I don't know that word.
The same abilities. Yeah. Reliability, observability,
Oh, got it. Which cause a bigger problem with maintenance standards, etc. Yes.
Yeah. So my problem with what Napalm Codes keeps saying is that he keeps saying things where pretty much all I can do is go, yeah, that's right.
It's so perfect. We have no discussion that can be had around this.
Dude, yeah, stop knowing what you're talking about. I think the most interesting thing about that last statement, though, is business logic concerns. And again, we're back to this concept that the point is to be able to accomplish something. The point is not to sit back and, spend all of your time as an applications developer figuring out exactly how to go through and, I don't know, how do I write my deployment? This is not, app developers do not get out of bed going, ooh, I get to learn to write a deployment today. They get out of bed going, oh, I'm going to solve this business problem. I'm going to solve this thing that's been vexing me for 6 months and I'm going to get it done today. And that feels good. It's also important because it's accomplishing something useful, right?
Yeah.
So that's, again, the thing I would focus on.
And it's not redundant work where every app team needs to do it for their particular application.
Yeah, exactly.
So reducing toil in that way.
Yeah. And some of the toil, like some of it isn't just toil either. If you sit down and you say, hey, application developer, I want you to implement retries. Yeah, that's kind of toil. That's, we generally know how to do that. If you sit down and go, we want you to implement MTLS. Some of them will get it wrong because that's a fairly specialized sort of thing. And so you can end up with, it's not just toil. Sometimes it's correctness as well.
Okay. Yes. Yeah. Good point. I want to say briefly, Napalm, please don't actually say, we know we're kidding, right?
Yes.
Like, please be your full and genuine self. And Findle, I want you to be your full and genuine self too. No need to try not to be an idiot. You can be an idiot. We like you all the same. Okay.
I actually missed Napalm's comment about, I'm sorry, I'll silence myself. So yes, please don't.
Yeah, please don't. Yes.
Yeah. Scrolling back a bit, I saw somebody asking about Istio versus console versus Linkerd versus WASI, and we will talk about, actually, we probably won't talk about WASI, but we'll talk about the other ones.
Okay.
Yeah. So
Okay.
there
What's
are,
next?
well, there are a lot of different directions we can go here. So let's go with a very high level diagram of kind of how most meshes do things. And that'll be a nice avenue to talk about some of the differences between Linkerd and Istio and console and things like that.
Great.
So in the context of Kubernetes, we can start by imagining a single cluster that has a few workloads in it. So you've got a cluster and there are a few pods running in it. And
Okay.
we don't really care how those pods came to be. You might want to give yourself a little bit of room in your cluster.
Okay. Do I need any room outside of my cluster?
Yes, for later.
Okay.
You might not need a lot outside, but yeah.
Okay. So this is my cluster. And how many things will I draw in this cluster? This is like turn
So
into
we'll start
Pictionary.
off, use like, wait, we have multiple clusters now.
Oh, no, this represents different altogether. It's a cluster. They're all different
Okay,
machines in the cluster. It's showing that there's more than one
great.
machine. How
Okay,
do you feel about that? Yeah.
yeah, I can work with that. So in this
Okay.
case, we're going to have a couple of pods inside that cluster that will be
Okay.
talking to each other.
Okay.
And for the moment, we're not going to talk much about, actually put the other one on the other side of the cluster. That might work out better.
Okay. I'm gonna make this lower just to maximize my space.
Yeah.
So I have one
This is
pod
how,
here and one pod here.
there we go. Great. This is how you know we haven't, colluded on doing any of this before.
All right.
Okay. So in your typical Kubernetes application, microservice app, those two pods need to talk to each other.
Yes.
And they will typically do this just with, some random clear text connection between the two. And there you go. We now have the very basic structure of a microservices application running in Kubernetes. We are deliberately not including the Ingress controller at this point because we're going to come to that later.
Oh, it's the outside. Okay.
Retrospect also is asking about the Istio ambient service mesh, and we will definitely talk about that, but we will talk about that later.
Thanks for joining Retrospect.
Yeah. It's also, when we do talk about things with Istio or console, I'm going to go ahead and throw this caveat out now. It is very, very important that everyone remember that I work with Linkerd. I am very, very biased. On the other hand, I also spend time working with Gateway API and Gamma, which is the service mesh extension to Gateway API. So I work a fair amount with people who are Istio maintainers and console maintainers and such. So I will try very, very hard to accurately talk about those products. But yeah, you got to remember I'm biased. So
and we're going to do an episode on Istio with Marino.
Right.
We'll do that next Thursday on October 12th.
So, right. So he'll be able to mock everything I say about Istio.
Yes.
Yeah. Or something like that. Okay. So that's your typical microservices thing running in Kubernetes where you just have these pods talking to each other. There's nothing going on. Service meshes work by introducing proxies. Well, most meshes work by introducing proxies. They'll put one proxy at each pod, and the communication will then end up flowing from the containers in the pod that do application work into the container that's the proxy. So I usually draw this one just by sticking little boxes inside the pod next to those. Yeah,
so
exactly.
Is the mesh like its own container running in the pod?
The way we're talking about it right now, yes.
Okay.
And the other thing going on in the cluster as a whole, when you start talking about the mesh, is there is also a control plane. And so The purpose of the control plane is that it is, on the one hand, managing all of those proxies. If you can put dotted lines between the control plane and the proxies, but it gets really messy if you do that. So
I'll start it there, and then we can
also just kind of take that
erase.
as read if you like.
So
Yeah.
this is
Cool.
a service mesh control plane or Linkerd specific control plane?
Most meshes have something in the role of the control plane, so I think it's okay to just write control plane or mesh control plane.
Mesh control plane. And then I have another question. Is the control plane typically a container or a series of containers, or like what's actually running?
So in Linkerd, which is the only one Linkerd is the only one I can talk about at that level of detail. Okay. In Linkerd, there are 4 distinct controllers that comprise the control plane.
Okay.
And we could talk about that now. We could, we could list them out now. We could come back and talk about it later. Up to you.
Since you know the big picture, I trust you about how best to tell the story.
Okay, so let's continue with sort of this high level bit. Okay. There are 2 really important things that the control plane does. One of them is it's managing all the proxies, but the other one is a rendezvous point for things like metrics. So those dotted lines both represent control, but they also represent metrics data that's coming back. And honestly, even that's playing a little bit fast and loose. The metrics in Linkerd's case, for example, go to a Prometheus, which you could argue is not really part of the control plane. But the point is that sticking those proxies in the communications paths lets the proxies mediate all the communications, but it also lets them measure all communications.
So the mesh control plane manages the proxies?
Yep.
And what's the second thing?
It's a central place to collect metrics and things like that.
Okay. Centralizes metrics collection. Honestly,
Kamaraju just asked if the proxy in the pod was the Linkerd proxy or Kube proxy. It is the Linkerd proxy. Kube proxy is a separate thing that is unfortunately a very similar and confusing name.
Yes. And then I just a quick hi to Code with Sean, another old friend here. Hello, Code with Sean. Thank you for coming. All right.
Also, Napalm Codes asks, the proxies are sidecars traditionally, right? Yes, they are.
And by sidecars, we need a second container, or at least like an extra container running in the pod in addition, alongside the application container.
Right. Generally, a second container injected at runtime into the pod, in fact. So that is actually one of the control plane components in Linkerd is the proxy injector, which does exactly what it sounds like, injecting that thing in there. It does a couple other things too, which we can talk about. Okay. That is your basic service mesh diagram, which also happens to be pretty much exactly the way Linkerd does things.
Okay. Mesh proxy, we'll call this. Is that accurate?
Yeah, for this level.
Okay.
So at this point, we can talk a little bit about some of the high-level differences between Linkerd and Istio and Consul, and we can go further down rabbit holes as people want, but at a very high level, most of the meshes, maybe all of the meshes, started off with this sidecar concept. Whitney, we seem to have lost your...
Yeah, this is a new thing that happened last episode too, where it just likes to forget my camera out of nowhere.
I've had that happen to me. There we go. Yeah. And now it remembered it out of nowhere. That's awesome.
Yeah.
Okay.
Great. Okay.
So like I said, most of the meshes, maybe all of the meshes Meshes.
The
Oh yeah,
murder of meshes.
I can
Yes.
speak English really well. Most of them started with the sidecar concept. I think all of them actually did.
Uh-huh.
The big difference is that the meshes that are not Linkerd tend to run Envoy for that proxy.
Okay.
Envoy is the thing that I think, so you've talked a lot about Ingress controllers, many of which are based on Envoy.
Yep. We did a emissary Ingress that uses Envoy, and we did Contour that uses Envoy.
Right. And
Yeah.
both of those, emissary and Contour, kind of joined forces for the Envoy Gateway project, which is unsurprisingly based on Envoy. And Envoy is interesting because at the time that people started doing a lot of meshes, Istio, for example, kind of leaned on Envoy, going like, oh, hey, we've got this proxy. This is great. And so they built their mesh based on that. Linkerd does not use Envoy. Linkerd's proxy is a custom-built proxy written in Rust with the sole purpose of being used in a mesh. And this has a couple of very interesting effects. So yeah, sorry, console, the mesh, not Contour, the Ingress controller. Console is also using Envoy under the hood.
Okay, I'm going to back up and make this simplified.
Absolutely.
So most meshes have a sidecar that's running a proxy, right? And we're saying most because now that there's ePPF on the scene, some things are different, right?
Really, it's more like Istio ambient mode is the first big change there.
Okay.
And we'll talk about eBPF as well.
Most
but most meshes use sidecars.
Minted as a sidecar, as a proxy in a sidecar.
I'd probably just say using sidecar, using sidecar proxies.
Okay, like it. Okay, and then do you know this one you're saying? So I know Istio, but I don't know Console. CONSUL. Is it it's probably not CNCF, and that's why I don't know it, because I have to limit my scope somehow.
I think you probably don't know it just because it has less of a footprint than Istio does.
Okay.
But now I'm gonna have to go look this up. I'm pretty sure it's a CNCF mesh or a CNCF project. I know it's a CNCF project, actually.
Yeah. Okay, I'll look into it. Istio and Console use Envoy. And then Envoy, I'll say, as part of learning from other episodes, is notoriously big, right? Notoriously like complex, at least. Yeah.
Heavyweight is the word I usually use in this context. And this is a point where I'd like to remind everybody that I was the original author of Emissary, and Emissary is based on Envoy. So my personal experience with Envoy, which spans several years, is that describing it as complex to configure is an understatement. Now, the flip side of that is when you use Envoy for a service mesh, the mesh is supposed to be managing all of that for you. So Envoy's complexity viewed from the perspective of a user of a service mesh is usually less of a big deal than the resources it consumes while running. Because if you're doing an Ingress controller, you may have, like 3 envoys running so that you have high availability. If you're running an envoy next to every pod that your application has, you might be running hundreds of envoys or thousands of envoys in your cluster. And suddenly their resource usage is important. You'll actually notice it. Linkerd's Rust proxy, we sometimes call that a micro proxy written in Rust. The Rust proxies tend to run at on the order of 1/10 of the resource consumption of envoys. And I'm going to emphasize the phrase "on the order of" because you can go through and measure that and get many different answers, but it's a lot less than an envoy doing the same kind of work. The other thing that we kind of like about the Rust microproxy is that we tend not to have to worry about a lot of the security problems that C++ code runs into a lot. So that's why we chose Rust, was for the data plane, which is the part that's slinging data around in a mesh. Keeping the resource consumption down is really important. Keeping the latency down is really important. And it's a security feature, right? You want it to be secure in its own right. And so using a proxy that does less than Envoy can help you do that. Now,
I have a question.
Go ahead.
So if you have this lighter weight proxy, you went over some benefits, which I'm totally sold on, but then there must be a trade-off. Like if you have so much of a heavier proxy, there must be more that proxy can do. Like,
there are definitely
what's the trade-off?
Yeah, there are definitely functional aspects of Envoy that the Linkerd proxy cannot replicate. 100%. Most of those things tend to be more important for an Ingress controller than for a service mesh proxy, which shouldn't surprise anybody because the Rust one was designed to be a mesh proxy, so the really important things for meshes are in there. And Envoy, to its credit, I think we should call out that the Envoy folks have spent a lot of time trying to make Envoy safe to run hanging out on the internet as a whole. And Linkerds, we've not spent nearly that much time doing that with the Linkerd proxy because it's a mesh proxy. It's not an Ingress controller proxy. So that would be kind of that kind of has less to do with what Envoy can do and more to do with the Envoy folks have recognized that is where Envoy tends to be deployed a lot. And so they've tried to focus on that aspect of things.
Great. Thank you.
Yeah, not a problem. Now, if you look back at that most recent thing you wrote in yellow where you said most meshes are implemented using sidecar proxies, the word most is important. And that gets us back to the discussion about, hey, what's the difference between Linkerd and Istio ambient and Istio and console and Cilia mesh and all that stuff, right? So at a very high level, and this is one where I have to be really careful, especially because Cilia mesh and Istio ambient get confused a lot, and they are actually pretty different under the hood, technologically speaking, as I'm confident Marina will be happy to talk to you about. Both of them, I think the most fair way to put this is that both of them are trying to get away from this need to put a proxy next to every application pod. And they are approaching this in kind of different ways, but that's the end goal, is to look at it and go, hey, maybe we don't actually have to put a proxy next to every pod. I think it's really important. Well, okay, let me back up a moment and say, as I think about it, I think I'm going to leave it to them to talk about the specific details of exactly how they do that.
I think that's wise.
An important difference in my head is, and it'll be fun to see what the individual implementers say about whether I'm right or wrong about this. But an important difference in my head is I feel like Cilium, actually, let me back up. A very important thing to note about both of these is there are still proxies involved. They often don't really talk about this, but there are very much still proxies involved. For example, Cilium likes to talk about, hey, eBPF, it's the answer to all our problems. And eBPF is really cool. But you can't do things like implement HTTPS in eBPF. It's the eBPF runtime won't allow you to do that. So eBPF is awesome at layer 4. And act like, people run Linkerd all the time on top of Cilium's CNI, which is using eBPF at layer 4 and does a great job. But there are things that you just can't do at layer 7 with eBPF. And so you end up having to have a layer 7 proxy in addition to all the layer 4 coolness. In Istio
Will
ambient,
you quickly Just say what level 4 and level 7
Oh,
are, just
sorry.
for folks who don't know. Yeah.
This is the increasingly
The
misnamed 7
OCI, yeah, model.
OSI, I think actually.
OSI, there it is. Yeah,
There's
okay.
it was originally stated as a 7-layer model.
Uh-huh.
It is increasingly misnamed, I think is a good way to put it. But broadly speaking, layer 1 is sort of the electrical signal on the wire.
Yeah.
Layer 2 Wait,
Wait,
sorry.
layer 1's the hardware.
Layer one is
Yeah.
the kind of wiring or whatever you're using, right? So are you
Okay,
using
yeah.
wires? Are you using a radio? Whatever. Layer 2
Yeah,
is how do
physical.
you actually do electrical signaling over layer 1? Layer
Uh-huh.
3 is how do you carve that into frames, which in the internet world is the IP protocol.
Okay.
Layer 4 comes in with UDP and TCP. We're
Yeah.
going to skip layers 5 and 6 because literally no one in 30 years has been able to agree on what layers
It's
5
like
and 6 really are. And we're going to
sockets
go
are in
straight up to
there,
layer
API
7.
something. Okay.
Yeah, layer 7 is where you get things like HTTP, HTTPS, gRPC, stuff like that. Um,
Okay.
it is, I'm not exaggerating. Literally, yeah, well, good point. Yeah. But I'm not exaggerating when I say that nobody has been able to agree on what layers 5 and 6 are in 30 years.
Code with Sean has it to level 4's TCP UDP, level 7's HTTPS stuff, and
And he is,
Texas. Oh yeah.
yeah,
Uh,
yeah. It's,
cool.
yeah, it's, I've sometimes thought about going through and, doing doing a podcast series or doing a live stream series or something that is things that we thought were true 30 years ago that we've since figured out are a bad idea and we should do it differently. And this would 100% be on the list. The idea of 7 layers is broken and wrong, and we should dispense with it immediately. Yeah, it's
All right.
yeah. So layer 7, HTTPS, HTTP, gRPC, all those application level protocols. Layer
Mm-hmm.
4 is dealing with UDP, TCP, port numbers and things like that. Port numbers,
Okay.
IP addresses, that sort of thing. So eBPF is great at layer 4, and it can do a bunch of very, very cool things, but you still need layer 7 proxies if you are trying to do a bunch of stuff with eBPF. I feel like Cilium, I feel like Istio Ambient is a little bit more flexible about where you put that layer 7 proxy than Cilium mesh is. And it'll be really interesting to find out what the Istio and Cilium people have to say about that when you talk to them, because I might be totally wrong about that.
Okay.
But there's one other thing that I want to point out, though, about that sort of non-sidecar-ish or limited sidecar or, something like that, that whole model of trying to get away from having a sidecar next to every pod. The first one is I kind of feel like it's a reaction to the fact that Envoy consumes a lot of resources when you use it as a sidecar, right? If you start with a sidecar that just doesn't use much resource, it's a lot easier to keep running sidecars.
Yeah.
And the thing that is nice about sidecars is that Kubernetes, and here we're going to go back to that idea that nobody runs Kubernetes just to say they're running Kubernetes, right? If your goal is to accomplish stuff with Kubernetes, that one of the things that's really nice is not having to invent extra bits of stuff on top of it and being able to use the existing models that people have already about. One of the things really nice about sidecars is that sidecars are inside pods. The surface area of a sidecar, the security domain of a sidecar lines up exactly with that of a pod.
Yeah.
People already know how to use pods. People are already kind of accustomed to this idea that, oh, hey, my pod is sick. I'll just shoot it and get another one, So operationally, and from the perspective of security and from the perspective of configuration, pods are really simple, and sidecars get to preserve that simplicity. One of the things, go ahead.
I think I want to write like a benefits of sidecars, maybe?
Yeah. Yeah.
Okay, cool. And we can
And
like summarize what you just said in that way.
yeah, the biggest benefits of sidecars is that they are operationally simple. And this is a long-standing goal of Linkerd, is to arrange things so that you can have the powerful part of a service mesh without having to bring in all of this complexity.
Mm-hmm.
So all of the operations that you already know about how to do with a pod work
Mm-hmm.
perfectly if you're using sidecars.
Uh, Pod operations work.
Mm-hmm.
And then can be lightweight.
Yeah. And the other thing I'd call out is that the security, let's call it the security profile of the sidecar matches the security profile of a pod.
Mm-hmm.
So I'm going to haul out a specific example of that. One of the things that Linkerd brings to the world, and indeed that most of the meshes bring to the world, is the idea that they can automatically do MTLS for pod-to-pod communication,
Mm-hmm.
which is a pretty big win. MTLS relies utterly on certificates. And
Mm-hmm.
one of the nice things about the sidecars is that a given sidecar only ever needs to have access to the specific certificate that identifies the pod it's a part of. There's
Mm-hmm.
never a situation where a sidecar needs, or where anything in the mesh needs access to more certificates than that. So
Yes.
you can have a situation where somebody could conceivably hack into a sidecar and recover their certificate for that specific pod, but there's no
Mm-hmm.
case where you could hack into a sidecar and recover the certificates for all the pods in the cluster.
Mm-hmm.
Actually can run into things like that if you change the security model so that you have your proxies no longer associated with individual pods.
Yeah, that makes a lot of sense.
Yeah.
Mm-hmm.
Um, and again, to be fair, the attacks like that are largely uncommon in practice, might be a good way to put it. But
Mm-hmm.
if you're actually really thinking about security, then having an answer, if you're really serious about security, you need to be able to address the fact that there's a best practice in security of isolating things to only the security domain they need and not giving access to anything else.
Least
So
privilege.
yeah, and that's a thing when you start getting into proxies or other entities that have access to multiple certificates and things like that.
Mm-hmm. And then that also, I mean, you're just almost describing one way that it's operationally complex without the sidecar model.
Yep. Now, once again, I am biased, right? Let's be clear, but again, my biases angle strongly towards thinking in terms of how you can make these things usable and powerful without having to make them complex for people who are not experts. So
Uh-huh.
I really like the operational simplicity that sidecars can bring to the table. One of the, you know, you can get benefit from running Linkerd as a 4-person startup. It's not even
Mm-hmm.
hard. And that's sometimes challenging if you look at some of the other meshes. Komaraju asks a good question. What happens to a sidecar when a pod goes down and vice versa? This is one of the great things about sidecars. Kubernetes pretty much has this thing built into it that guarantees that when a pod goes down, it's the whole pod. So when the pod goes down, the sidecar goes down with it. And then when Kubernetes restarts the pod, the sidecar comes back with it. And once again, it all just works.
Yeah. Is it the pod knows that like whatever containers it's supposed to be running has to be healthy. If either container's not healthy, the whole pod goes down, correct?
Yeah, basically.
So there's not an
There,
instance where the proxy pod, the container would be down and the application container would be up from within the
yeah,
pod. That would kill the
we're
whole pod.
yeah, we're
Yeah.
we're playing slightly fast and loose with a little bit of things about Kubernetes. There are I have seen bugs where you can end up with things lingering on in kind of a zombie state when they're not supposed to linger on. But the goal from Kubernetes point of view,
Conceptually,
the
yeah.
goal from Kubernetes point of view is if anything goes wrong, the whole pod gets shot, and that usually works out pretty well. Your comment about there goes your camera again.
There goes my camera again.
Your comment about the pod knows which containers it's supposed to be running is kind of a nice segue into talking a little bit deeper about how the Linkerd control plane works. If we want to go there, we actually have two things that might be good to try to cover fairly quickly. One of them is certificate management, and one of them is something of a deeper dive into the control plane. While Whitney is figuring out camera issues, y'all on the chat, do y'all have an opinion about which you'd be more interested in hitting first?
What are the choices again?
Certificate management or deeper dive into the control plane. And retrospect, while we're waiting for stuff like that, comments to sum it up, eBPF is limited in capability, complex to implement, and still needs time to mature. I would agree with all of those things. I think it's important to add a little nuance to limited in capability, which is that eBPF came from BPF. BPF is much older than people tend to think it is, but the original take for BPF was solely about managing packet switching way down deep in the hardware, and eBPF is still great at that. The limited in capability part, to me, is mostly something that comes into play when you start talking about trying to push it further up the networking stack.
Huzzah!
Woohoo! Great. Retrospect also says Linkerde's approach seems to be to stick to the sidecar model due to security, simplicity, and more. Just make the sidecars more efficient. Basically, yeah. I mean, yeah. Trade-off, lack of benefits of sidecar when moving one piece to the cluster level. Yeah, that's as you start to channel one of my Gamma colleagues from Istio. They tend to argue that moving some of the proxying up out of the individual pods provides for more flexibility. And I think they're probably correct about that. And I would counter that the cost is a lot more complexity, which I personally tend to not favor very much.
Live coding has thanks for coming. Live coding has says they prefer a control plane deep dive, which that's my vote too. But Avo says certificate management. So yeah.
All right, so we're gonna try. We'll try to do both.
Okay.
Let's talk a little bit about the control plane, and I think this can all retrospects our tiebreaker for the control plane. Okay, so this probably, in terms of drawing, you could try to cram this into your existing cluster, but you might have more luck just writing it above your head.
Okay.
There are 4 components within the Linkerd control plane.
Okay.
3 of them are controllers. We have the identity controller, the destination. Actually, let's do it in a slightly different direction. We have the policy controller.
Okay. One.
All right. We have the policy controller.
Mm-hmm.
We have the destination controller.
Okay.
We have the identity controller. And finally, we have the proxy injector.
Oh.
Now, I'm gonna talk about the injector first, but I wanted to list the three controllers first because they are all kind of a little more strongly related to one another. A very important thing to start by pointing out here is that in Linkerd, the thing that makes all the decisions about what's going to happen with traffic that's the proxies making all the decisions. The point of the
Okay.
plane is to give the proxies the information that they need to make the decisions, but the proxy is where all the magic happens. So let's quickly start by talking about, we can quickly start by talking about the proxy injector. The first thing that the proxy injector does is that it is the thing that actually modifies the definition of a pod to include the sidecar.
Okay.
And there are a couple of different ways you can tell Linkerd that it should be doing this. One of them, like you can put an annotation on a namespace that says, hey, any pod that shows up, please go and inject it. Or you can put an annotation on the pod itself, But the point is that however the pod appears, the proxy injector will realize that a pod has appeared, and then it will go and edit its definition to include the sidecar. And that ties us back into the question about what happens when a pod dies. What happens when a pod dies is Kubernetes removes it from the cluster. Usually, if it's a pod being run by a deployment or something like that, Kubernetes will then create a new pod for it. The proxy injector will see the new one, and it will re-inject the proxy back into it. The other thing that the proxy injector does is it sort of kickstarts the configuration of the incoming proxy so that it will gather a bunch of information about its environment and kind of hand that to the newly created proxy to say things like, right, here's your workload and here's some other stuff and things like that. So it does the first bit of configuration of the proxy as the proxy goes in.
What gives a boilerplate configuration to proxy?
Yeah, that works.
I have a question. What
Shoot.
about I've very theoretical, right? I've learned that best practice is to have everything perfectly declarative. So if we're injecting this at runtime, like I feel like I want like a definition in Git that I can use for GitOps. Like, is that a thing?
The simple way to do this with GitOps, and I'm hesitating here because I don't want to go too far down that particular rabbit hole.
Okay.
But yes, there is a way that you can sort of just put the proxy's definition in there without using the injector. Some people do GitOps with that.
Okay.
And if you want to learn far more about this than you ever wanted to, you can come to the Service Mesh Academy where we do Argo.
Okay, cool.
Or you can go back and rewatch the Service Mesh Academy where we already did Flux and Flagger.
Okay. Excellent.
Yeah, it's it can be kind of interesting. The declarative aspect actually is an interesting thing to note there. Yeah, it's the whole mutating and mission controller and GitOps is interesting. Yeah, that's a good way to put it. Let's just leave it at that.
Great. Sounds good. Maybe a topic for a future Enlightning.
Yeah, oh, you should definitely do an Enlightning on GitOps. That would.
Oh, I have one on GitOps generally, but like on GitOps and Service Mesh together.
Well, in that case, I apologize for not having already watched the Enlightning on GitOps.
Oh, that's okay. There's one on Argo CD and one on Flux and one on Carvel Cat Controller, which is a third. Yeah.
Mm-hmm. Cool. Okay. So the first thing that the proxy does after kind of coming to life is it then turns around and talks to the identity controller. The identity controller is a CA in the sense of MTLS and certificates and all that kind of stuff. So pretty much the first thing that the proxy does is makes itself a certificate signing request and hands it off to the identity controller, and the identity controller verifies that the CSR is valid and hands the proxy its certificate identifying itself. And technically, the proxy hands off its service account token using a Kubernetes service account. So it hands off the service account token, and the identity controller verifies the service account token, and see previous comment about rabbit holes.
It verifies the proxy CSR using a service account token.
Right.
Cool.
And this brings us to another important distinction between Linkerd and some of the other meshes, which is that Linkerd very deliberately does not associate any of your workload's identity with the network. So your IP address is not part of your identity. Nothing about the network is part of your identity. Linkerd does not care about your network topology at all. And that can also be a bit of a difference.
Okay.
Right. That certificate that's being issued, that's the thing that participates in MTLS. That's the thing that Linkerd policies are based on. And none of it has anything to do with the network.
Great.
How about say based on network, actually? I think you have room to squeeze that in. Because, just for anybody reading it afterwards, we do, in fact, toss network identities around over the network, but we don't base them on anything with the network. Okay. After that, the policy controller and the destination controller work together to give the proxies information about endpoints that they can talk to and about what things they are allowed to talk to.
Okay. Destination controller and policy controller work together.
Yep.
With the proxy.
Right.
And
most of the time when you get a network request with Linkerd, and I'm feeling a little bit silly because clearly I should have talked about those. I should have listed those in the reverse order, actually.
It's cool. We're making it work.
But most of the time when you are talking, when a request is made, what you actually know looking at the request is the cluster IP address of the workload that you're trying to talk to. And so one of the important things that the destination controller can do is to tell you, oh, hey, given this cluster IP, here are the actual endpoints of the pods managing, behind that service. So there's a resolution step where you go from a service, a Kubernetes capital S service, its cluster IP, you need to get from there back to the IP addresses of the individual pods behind it. And that's an important thing that the destination controller does.
Okay. I missed what the destination controller and policy controller and proxy work together to accomplish.
To figure out to whom the proxy should talk and whether a given proxy is allowed to talk to it.
Okay.
While you're writing about that, Kamaraju is asking, what's the role of kube proxy when we inject a pod with a sidecar service mesh? Not a lot, actually. One of the things that happens when you're using a service mesh is you mostly end up kind of going around kube proxy.
Oh, interesting.
Kube proxy basically doesn't do a very good job of managing a lot of traffic. Not in the sense that it's a badly written piece of software, but in the sense that, for example, basically the only thing that kubeproxy really understands is connections. So if you make a TCP connection and then you spit something over and you get an answer and then the connection drops, great. But with things like HTTP2, you'll make a single connection and then funnel gobs and gobs of requests down that one connection. And effectively doing load balancing means that you have to understand the request, not just the connection. Kubeproxy does not understand that. Linkerd and the other meshes do understand requests. So one of the big things is, as the moment you put in Linkerd, suddenly things like H2 and gRPC start seeing request level load balancing, and it works much better than letting kubeproxy do connection level load balancing.
The more I learn about Kubernetes networking, the more I realize I don't know. You know, the more I know, the more I don't know.
It's kind of appalling, yeah. It's.
But also, what's interesting about anything networking related, it's like, oh, here's this Kubernetes built-in thing, this Kubernetes ingress object. Yeah, we totally don't use that. We just made our own thing because there's room for improvement there. And now I'm hearing that about a lot of different aspects of Kubernetes, where there just isn't a controller, or we just don't even want to use that object, or get around kubeproxy, which I thought was an integral part of Kubernetes. It's amazing.
Yeah, there are some really interesting conversations to be had about that, because a lot of this also reflects the fact that Kubernetes came onto the scene at exactly a moment where a bunch of things were about to change very quickly. And trying to figure out how to adapt Kube to keep pace with those changes has proven really difficult. Partly, in my opinion, because Kubernetes is an open source project that's largely run by people for whom that's not their full-time job. And it's a pretty complex open source project that actually needs people to be devoting their full time to it. So that makes things kind of challenging. The Gateway API is a good example of that, where Gateway API is a reaction to the fact that the ingress object, the ingress resource, was pretty limited and couldn't do a bunch of things, but also that they ended up going the CRD route with the Gateway API because that seemed like the way to get it done more quickly. So which is really interesting when you think about it.
Yeah, we want to improve Kubernetes, but we don't want to be tied to their releases. So we're not going to actually improve Kubernetes from inside Kubernetes. We're just going to make a whole new thing.
So you kind of have to start asking questions about, maybe we should figure out how to improve the release cycle, or maybe we should figure out how to make it more possible to do this stuff inside. Yeah, things like that make me feel bad, because I didn't have enough bandwidth to dive into Gateway API right when it got started, and I had to come into it a couple of years later. But
and also at this point, so much has been built on top of it. It's hard to change anything foundational.
Yeah, it really is.
It's about breaking half the world.
Networking in general is a similarly complex topic, where you learn some things and then you find out it's turtles all the way down, and you start having to deal with things you had no idea. My favorite one for networking in general is the speed of light is now a factor for networking in general. Yeah. And you kind of go, really? One of the big problems that that people have been wrestling with for a little while with TCP is it works great for terrestrial stuff, but as soon as you start thinking about, suppose we put a space station on the moon, or suppose we have stuff on Mars, and you find out that it doesn't work very well, right? It's like, oh crap! Now what do we do? Yeah.
That's funny.
It's that was a lot of fun to run across. Anyway, so back to service meshes and the service mesh turtles all the way down problem.
Yes.
Yeah. So you have this situation where you need a way to go from a cluster IP to information about what service you were trying to talk to in the first place, and the destination controller and the policy controller both. They manage the issue of getting to a set of endpoints.
Excuse me.
I know, you're allergic to Linkerd, I'm sorry. Or allergic to networking.
What's a cluster IP? Oh,
When
like
you
a
make,
cluster IP. I got it. I got it. I was
yeah,
for
when
some reason
you,
I was thinking of an actual. Okay, so it's a one of the services in one of the
right,
capital S Kubernetes
right.
services. Yes.
A Kubernetes service resource turns out to be way more complex than people typically think, because it has multiple jobs that all get kind of crammed together in one service or in one
Mm-hmm.
resource. One of them is that it needs to allocate a DNS name. One of them is it needs to allocate a cluster IP for the service as a whole that you can just talk to. But it
Mm-hmm.
also has to manage kind of the bag of endpoints that belong to that service as well. And those three problems are actually really, really different. And the fact that they got crammed together into one resource makes life really interesting a lot of the time.
Let's make a
Um,
new resource as a separate project.
yeah, it's being discussed. Yeah,
So we
but
need a way to get from that cluster IP service,
the
cluster IP
cluster IP for the
service,
service.
cluster IP
Yeah,
for the service. Got it.
you
Okay, but there's not an
basically
actual IP address. We're talking about the service
it
type called
actually
cluster
no,
IP.
there actually
There
is
is
a there is a
there is
so
an IP address
yeah
associated with the cluster IP.
when you make a
Yes.
service, um,
Uh-huh.
one of the things that it does, unless you explicitly tell it not to, one of the things that it does is it goes back to Kubernetes and says, please give me an IP address that can be used from anywhere in the cluster
Mm-hmm.
for somebody who wants to talk to me as a service without thinking about endpoints. And
Yes.
we call that the services cluster IP.
Yes.
Um,
And the type of service is called cluster IP also, which is
but it
where my
might also be
confusion is.
but it might also be called same thing happens with a load balancer service.
Uh-huh.
I think the same thing happens with a node port service. I'm not entirely
Yes.
sure about
Well,
that.
it's
Yeah,
turtles. Like a node port makes a cluster IP.
yeah. It's a
Load
load
balancer
balancer makes
makes
a
a
node.
node port, makes a cluster IP. Yeah.
Yeah, and
Uh,
so in the mesh world, when you start talking about gateway API for mesh, Gamma, we actually had to develop vocabulary to talk about the front end of a service, which is its cluster IP and DNS name, versus the back end, which is all the endpoints, because meshes
uh,
actually care about that. And
yeah.
one of the fun questions you get into are things like, well, suppose your ingress controller talks directly to an endpoint IP rather than talking to the service's cluster
Uh,
IP. What do you do there?
yeah. Yeah.
Because if you see a connection from the mesh's perspective, if you see a connection to a cluster IP, you can always go from there back to a service, the service
Uh-huh.
resource, because cluster IPs are one-to-one with services.
Yeah.
But a given, endpoint IP could belong to more than one service, and so it is generally not possible to go from an endpoint IP back to a service name. And so if you look up in the Linkerd docs, you will find out about Linkerd's ingress mode meshing, where you require the ingress controller to pass down a header saying, this is the service I was trying to talk to, so that we can do useful things, even if the ingress controller can't talk to a cluster IP or doesn't or refuses to.
Fascinating.
Yeah.
Okay.
So the
So with
destination controller and the policy controller, those are the things where the proxies work with them they will see a request going to a given IP address. They'll work with those two controllers to figure out which service that really is, and
mm-hmm,
to figure out what policies are associated with that service, so they can make
mm-hmm.
decisions about whether that connection should be allowed or not, and whether the connection should do retries, and whether this connection has a timeout, and all kinds of stuff like that.
So we need a way to get the traffic from the cluster IP to the proxy and whether it's allowed.
Right.
Yeah. And so the policy would be whether it's allowed.
Yep. And obviously I am glossing over lots and lots and lots of things talking about this. The reason that there are two controllers, and the reason why it's not just the destination controller handles the destinations and the policy controller handles the policies, is historical reasons that will be cleaned up shortly.
Oh,
Um,
so you are going to put it into one controller eventually?
Eventually, I think the separation between the two will be cleaner, but if you actually go look at it right now, there are places where they kind of overlap, and so it's handy to talk about both of them at once.
Cool.
Yeah. Because Linkerd is fairly old at this point too, and so Linkerd itself has been evolving. Linkerd has been evolving fairly quickly since version 2.12, where we brought gateway API resources in. And lots of things start changing when you do that. So that's the really quick overview of the control plane.
Mm-hmm.
Let's see if we can quickly do an overview of MTLS and certificates, because that will also let us talk a little bit about Linkerd multi-cluster, which is kind of cool.
Okay.
And this is another one where you can probably start out writing over your head.
What was the extra space outside of the cluster for? Is that still coming up, or is that fair game now?
Actually, I think that's fair game. Let's draw a
Okay.
couple of certificates up there. Actually, well, let's
Okay.
draw. Maybe put a dotted line from your cluster up over the top of it, and then we'll put some certificates in there.
Okay.
Inside the cluster, you can first draw a certificate next to each of those sidecar proxies.
So by certificate, maybe like a lock?
Yeah, that's fine. And those should be different colors, ideally.
Okay. From each other?
Well, the problem here is that you really want 4 different colors. And I'm not sure you have 4 different colors, right?
I have blue, but it doesn't show up very well. So
all right.
We'll try a blue. See what happens.
Yeah, we'll try
Getting
blue.
crazy here. Yeah.
Woohoo!
Yeah. Blue and a green.
So the important thing here, the reason that I wanted different colors for those, is that as we have drawn this, we have drawn pods that are distinct from each other. And if we assume that those 2 pods belong to distinct workloads, they will have probably distinct certificates because they're probably not running with the same service account. If they are running with the same service account, it will not be possible to distinguish between them as far as policy goes. So you probably want to distinguish between them.
Yes.
Now, above the mesh, or sorry, above the box, above the box for the cluster, like I said, you can draw sorry, let's put this one inside the cluster as well, maybe in the middle.
Okay.
You can put another lock in the middle of that cluster. In red or pink or whatever color you call that. That is the identity issuer certificate. And it signs both of those workload certificates.
Okay.
Yeah. The identity issuer is the thing that the identity controller uses to sign the CSR and produce those workload certs. So we have a trust relationship between the workload certs and the identity issuer. Now on top of the cluster, in green, I guess. Yeah.
So this is a common pattern in this type of in PKI, right? That use certificate hierarchies.
Yep.
Yeah,
it's somewhere between common and necessary. And we'll talk a little bit about that after you. Yeah, we'll talk a little bit further about that after we draw the last certificate we're going to draw here, which is the trust anchor, and that can be in green. Here. Yeah, that can be in green on top.
Okay.
Now, it signs the identity issuer.
Okay.
And the reason we're drawing that outside the cluster here is that a best practice for Linkerd is that you don't put the private key of the trust anchor in your cluster. You will have a copy of its public key in the cluster because everything in the cluster uses the chain of trust there. What actually happens with MTLS is that the pod on your left there talks to the pod on your right. And since this is MTLS, they will both exchange certificates. And both of them will then walk up the trust hierarchy until they get to the trust anchor, and as long as they both find a chain back to the trust anchor, then everybody will be happy and MTLS will succeed, and this is good.
Mm-hmm.
If they cannot find a chain all the way to the trust anchor, the connection will fail because that's a problem. But a really interesting thing here is that we use, yeah, there we go. A really interesting thing here is that since the trust anchor is not in any way tied to the cluster, that means that you can fire up a second cluster using the same trust anchor in Linkerd in the second cluster, and now you can have trust relationships that span clusters. So Linkerd multi-cluster, you can draw a second cluster over there in your empty space. And Linkerd multi-cluster actually relies on that, where it just works to do MTLS between the clusters as long as they both have the same trust anchor.
Cool.
It's also worth pointing out that in a lot of cases, for example, maybe you're doing this with, in a corporate world where you've got the corporate security office and you've got the CISO and you've got all this stuff where they have their very own CAs and everything. The trust anchor does not actually have to be a CA root certificate. It can in turn be signed by something else, and that is fine. But the trust anchor is the point where Linkerd stops.
Oh, I'm above the view.
If you don't care about having space for yourself, then you could draw another cluster underneath that and put the trust anchor in between. And but
oh, okay. Trust anchor. Cert.
right. And those trust anchors need to actually be the same certificate, not just have a signing relationship. Right. So once you do that, then MTLS, that cluster will have its own identity issuer cert signed by the same trust anchor.
Got it.
Now, I have no idea how to draw this given the stuff that's already on the board, but there are actually two different ways Linkerd can do multi-cluster. One of them, if your clusters don't have a shared network between them. So for example, you could do this where you have a GKE cluster and an AWS cluster, but they can talk to each other over the public internet. So you can use that where Linkerd will have a gateway service and a pod in your, the cluster on my left, the one with all the things drawn in it. So a pod in that one, a pod in that one would end up going across the public internet to the Linkerd gateway in the other cluster, and then from the gateway to a pod in the second cluster.
Okay.
That's actually, if you're trying to draw a gateway, you should draw the gateway in the other cluster.
So, okay.
This is something.
So it's a gateway service, right?
Yep. We usually call it the Linkerd gateway.
So it doesn't look like a pod. And then it has a pod associated with it. Yes?
Yeah, it does. And then, so draw another, another normal pod over in the cluster you're in right now.
Yes, a pod here and a pod here, and they talk to each other, right?
Right. But also draw one of your green workload pods over there.
Over here?
In, over there.
Okay. Okay.
So there will be basically you end up with, let's do this actually. The thing that you drew in pink next to the gateway service, how about go over that in yellow? And we can call that one a sidecar. So what ends up happening in this case is that the pod in the fully drawn out cluster, its proxy ends up talking to the proxy next to the gateway service, which ends up talking.
Oh, you split up.
Did that
Are
make
you
sense?
there?
Oh wait, right.
So
Okay.
the
Yeah.
workload
So that
pod. Oh,
so the
you're
proxy. Uh-oh.
okay.
Come
You're
on,
I think
internet.
you're
We're
back.
talking about good things with you.
The proxy in
The
the workload pod is talking
right,
to
talking to
this,
that,
which is
and
what?
that one, that's the proxy in the gateway service, and then that proxy
Okay.
talks to the workload pod's proxy in this other cluster.
Okay. So this one doesn't exist.
Right. You want to get technical about it. It can exist if you need to have bidirectional stuff, but we're only drawing one direction right now.
So that, and then
that one talks over to a proxy in there. Live coding says, I'll just say the gateway pod thing sounds impressive, and I dearly hope I will never ever use it. It's really, really cool. And then go ahead and draw a yellow proxy in your workload pod on your left.
Gotcha.
Okay.
So really.
And the other thing that's worth noting is that all of the communication you just drew out is MTLS.
All right. Cool.
So the thing that's particularly cool about this is that since that is MTLS, it doesn't matter what kind of network sits between the two clusters at all. And nothing about the network topology here matters because nothing about Linkerd identity is associated with the network topology. Now, as of Linkerd 2.14, we also have a cooler version of multi-cluster. Yeah. Sorry, go ahead and draw the certificates while I'm talking about that.
I wanted to capture that. So,
yeah, I know there aren't enough colors.
cluster specific ID issuer cert.
Yep.
And then we have our
and then you've got
workload specific one.
Yep.
And then what color haven't I used?
Blue, I think.
Yeah. So this one issues, this one issues, this one.
And the gateway has its own workload cert as well.
That's issued by the issuer cert here.
The yellow issuer cert.
Here's this one.
Yeah. Okay. Now, starting in Linkerd 2.14, we have a cooler way of doing this, where if the two clusters are on the same network, such that a pod in one cluster can just speak across the network to a pod in the other cluster, you don't need the gateway. You don't need the gateway anymore. And so a pod in one cluster can literally just do MTLS directly across the network to a pod in the other cluster, and it's faster and identity. So in the one that you just drew,
what version of Linkerd? With Linkerd
2.14.
Okay. If what conditions happen?
If your network supports direct pod-to-pod communication.
Okay.
Between clusters.
Will you tell me a case when that happens?
I've demoed it a lot with K3D, for example.
Okay.
It's the sort of thing that you can often set up in cloud providers.
Uh-huh.
It's tricky to set it up across cloud providers. I don't know if that's
I
actually
imagine.
possible.
Yeah.
But yeah, if you're working within a single cloud provider, then there's often a way to make that. You'd like assign them both to the same VPC and do some routing magic and crap like that.
Cool.
But if your network supports direct pod-to-pod communication between clusters, then the gateways go away. And in that case, your clusters start acting like they're just one big Linkerd cluster, and literally everything about the way Linkerd does MTLS and policy just works like it's all within the same cluster. And the reason for that, or the reason for implementing that, is that over time we kind of see multi-cluster evolving. In the beginning, we would see people where they'd have their main cluster and then a disaster recovery cluster, and then we started seeing people going like, "Oh, maybe we should have we could do like region by region clusters. So we've got the North American cluster and the European cluster, but they can backstop each other."
And
more
here's one
recently,
for each team. And now we acquired this new company, so let's bring on their cluster. And
yeah, and now we're seeing people doing more things like, "Oh, we used to use namespaces for isolation between teams. Let's just throw clusters at it instead." And so you end up with clusters wanting to be used more cooperatively. So arranging it so that they can act like a seamless larger cluster is kind of cool.
That is kind of cool. Because then people have root access if they need to install tools onto their cluster, but then they can communicate between other, microservices or whatever. Makes a lot of sense.
Or just, you can do things like, we don't necessarily have to care what namespaces are in the other cluster. We'll just let them do their thing. But then, you'd still need to coordinate with the people cross clusters or something, but it could be simpler in that respect too.
Or you can define what you want your proxy to do exactly in one place, and then that can be propagated throughout the whole estate instead of maybe.
Yeah.
Cool.
There are, we glossed over the fact that there is a service mirror component that is part of Linkerd. That's mostly relevant because it's probably important to notice that if you are doing multi-cluster, you don't have all the services from one cluster just magically appear in the other one, because that would be bad. So you have control over what gets mirrored to across clusters.
Do you want? We can capture that.
Okay.
You want to? Yeah.
Full snobble is, dear God, multi-cluster. Yeah, well, welcome to 2023. Here
we are. Okay, so Linkerd mirror component, and that is just another custom resource.
It's a thing that it's kind of another part of the control plane when you're running multi-cluster. The Linkerd service mirror.
Okay, we're gonna call it bonus.
Live coding. I think it takes 13 connected clusters to create a hell portal, but otherwise you're fine. Yeah, sounds about right. I can tell you from personal experience that at many numbers smaller than 13 feels like you're creating a hell portal. Yeah.
Okay, so our bonus control plane component is called mirror. What's it called?
Service mirror.
Service mirror.
Yeah. And it's multi-cluster only, and it's a way to control which services in other clusters are available from your first cluster. It actually works using Kubernetes labels for those.
Which services from one cluster are available in another?
Yep. And the service mirror is relevant whether you use the gateway component or not.
Okay.
Yeah, I feel like there was something else I was going to say, and now I've kind of forgotten what it was. So I guess it wasn't that important. Awesome.
It'll come back if it's meant to.
Or somebody will ask a
Okay.
question, and I'll go, right, that was what I was going to talk about. Yeah.
Cool.
If I did not mention it before, I was going to say that when you're doing direct pod-to-pod multi-cluster, you still must have that trust relationship between the trust anchor and all of the identity issuers for all of your clusters. Oh, that was the other thing I was going to say. Linkerd handles rotating the workload certificates for you,
Oh,
but
nice.
you do have to worry about rotating your identity issuer and your trust anchor, and we will typically, like setting things up so that Cert Manager is rotating your ID issuers is usually a good idea, for example.
Yeah, Cert Manager's wonderful.
Yeah.
Everyone agrees. No one has any beef with Cert Manager. It's everyone's
Eh,
friend.
I mean, I would like to have a way to have Cert Manager trigger jobs to run after it rotates a certificate.
Okay.
I think that's about it. I don't know if that's a
Nice.
beef or that's probably just a feature request. Yeah. Cert
All
Manager is
right.
pretty
Well, will you repeat what you just said more or less?
Linkerd handles rotating all your workload certificates.
Oh, the workload certificate.
Oh, sorry.
Okay.
Regarding trust,
Yeah.
anytime you do multi-cluster, all of your
Mm-hmm.
clusters must have the same trust anchor.
Yes. So you couldn't like chain it together where this one has, because there's only one trust anchor cert, so that doesn't make sense. Okay.
Right.
Uh,
Full Snapple. Good thing trust is easy. Yeah. Yeah. And it never gets more complex when you're dealing with corporate security offices or
I
standards
used
or anything like that, right?
I used to trust other humans easily, but then I got into tech. Um, so regarding trust, anytime you do it multi-cluster, all clusters
All
must
the
have the same
clusters.
trust. Okay, and
Right.
then Linkerd handles rotating workload certs.
Right. But you need to handle rotating the identity issuer and the trust anchor.
Is there any reason you would do something besides Cert Manager for that? Maybe if you have your like internal certificate.
If you've decided that it's critically important to you to run your very own cert manager own thing, I can't. I'm having a
Even,
really
yeah,
hard time thinking of one.
yeah, because if you like, you can make your own CA with that you use within Cert
Yeah,
Manager. It can be compatible with, yeah.
I think the only real reason would be if you're, well, real, right? I can imagine scenarios where there was some sort of dictate from on high that anything dealing with certificate management had to be developed in house and vetted by the security office or something like that. But
Mm-hmm.
I can't think of any actual defensible reason to not run cert manager.
Uh-huh. Probably with Cert Manager.
Yeah, it turns out to be getting cert manager to handle rotating the identity issuers fully automatically is pretty easy, and we've talked about that
Yes.
in some SMAs. Getting cert manager to rotate the trust anchor automatically is kind of tricky because there's one step that cert manager just does not have enough information to know when it happens.
Ah.
But that's okay because the trust anchor is kind of special and tends to be rotated slowly. I guess we have to stop because we've kind of boxed yourself in.
There's like a little room down here. I can fill in some things in between. If we have more to say, we can make it fit. But
Well,
it's,
I'm not sure what
yeah,
else we have to say really. It's yeah.
this has been such a joy. One thing I
Okay.
think I'd like to go over is we kind of talked about it with when we went over the control plane, like how it all happens in a linear way. Like you were like the proxy injector makes the proxy, and then the proxy reaches out to the identity controller to get its certificate,
Right.
and then it reaches out to the destination and policy controllers to figure out
It
who it's allowed
actually
to talk to and why.
it actually does that bit of reaching out to the policy and destination controller as connections come in. So
Oh, okay.
because that's information that can be fairly dynamic. You can
Uh-huh.
change off policy, for example, and things like that.
Uh-huh.
Um, and so as a new connection comes in,
Mm-hmm.
then Linkerd will talk to the policy and destination controllers. There is a cache for a bunch of that stuff. Don't be too horrified by the idea of that being always in the critical path. Um, but yeah, the point there is that you can change things that are stored in the policy controller, or endpoints might go away, for example, and so the set of endpoints will change.
So to create connections or to set up service mesh, like these are three steps that we went over. What's the three steps to do what?
What we were talking about was the steps by which a proxy starts running and then handles a request.
Yeah.
Uh, we have not really talked about how you, the human, configure the proxies. Um, Mostly because that's usually fairly straightforward. Linkerd only has like I think we're up to 6 CRDs now.
Mm-hmm.
There aren't a lot of them, but the three steps for a proxy to be handling requests.
Three steps for a proxy to handle requests.
Yep,
Proxy gets created by the proxy injector, kind of.
yep. The
Okay.
step one would be the injector starts the proxy running, or injects the proxy, starts it running. And
Okay.
then two would be the proxy talks to the identity controller for certificates. Well, really for its certificate.
Okay.
And then step three is per request,
Per request.
the proxy will check with the policy and destination controllers to get updated information about what to do with that request.
Policy and
And
destination
destination.
controllers to know what to do.
Right.
Cool.
And I guess maybe down in the your lower left, yeah, we have a little bit of space down in the lower left where we could talk about, or sorry, underneath yeah,
Okay.
even trying to describe things on a light board is weird. Um, oh, wow. I just realized, no, I should be saying you're right. Never mind.
That's cool.
Um, mirrors are terrible. No, you were in the right place. I just realized I was forgetting that it was flipped.
I just was
Um,
going to where I could see you until we know what
got
we're writing.
it.
This
We
is
can talk about the CRDs that Linkerd uses. We have a thing
uh-huh.
called a server with a capital S. We have a thing called a service profile.
I have a question.
Shoot.
Would you refer to these controllers as CRDs?
Nope. Those are
Okay.
controllers. They read
CRDs are
CRD.
controllers. And then the controllers have the logic to make the desired state that as defined in the CRD into
Yeah,
an actual state.
right. Live
Um,
coding actually, um, live coding mentioned a couple of questions that let's write down the CRDs and then get to the questions.
okay.
Linkerd CRDs, we have a server CRD, which is a lot like a service, but it includes information about port numbers as well. We have a service profile CRD.
Okay. Server. Want to say server. What a server is?
It
Like yeah.
it defines a. It really is a lot like a service, but
Okay.
slightly more granular than a service. It lets you
Okay.
associate things both with a name of a service and ports. So you can, like, if you have a service that defines
Mm-hmm.
ports 80 and port 443, you could have a separate server for port 80 or port 443. So you could talk about policy that is different, whether the traffic is coming in on clear text or TLS or whatever.
Okay. Like a
Uh,
Kubernetes service, but more granular.
right. We have
Okay.
a service profile, which is a little complex to describe, but fundamentally, uh, it's a way to, you can use it to define characteristics of a service, like whether you want it to do retries, whether you want it to have timeouts, and also it is a way to talk about HTTP paths in requests.
Mm-hmm.
We have the authorization
So,
policy. Go
quick
ahead.
question: a way to define characteristics of a Kubernetes service or of the server?
Let's say of a workload is probably better, actually.
Okay. Love it. Cool.
That's, yeah. We have a thing called an authorization profile.
Mm-hmm.
And it's funny to realize that I always think of that as an auth profile. And I'm going to go double check to make sure that it is an authorization profile and not a Linkerd, or sorry, not an authentication.
Oh,
Um,
yeah.
it is authorization policy, in fact. I'm terribly sorry. I said that
It's
wrong.
okay.
This is how you know
Easy
we're
fix.
doing this live or something.
Excellent. And these are these exhaustive?
Uh,
Depends how much space is on the board.
oh, in the sense of the exhaustive set of
Yes.
CRDs,
Uh-huh.
pretty much. We don't have a
Okay.
lot.
Okay.
Um, authorization policy does exactly what it says on the tin.
Uh-huh.
It describes, what is authorized to access a given thing. And I'm
Uh-huh.
deliberately being vague about thing because a thing can be a server or an HTTP route.
Okay. Describes what is
Um,
authorized.
yep.
Uh-huh.
And we also have
My God.
HTTP route, which we borrowed from the Gateway API.
Yes, it's familiar.
Yep. Which at this point overlaps a lot with service profile, actually. And one of the things that we're working on is kind of reconciling those so that we can deprecate service profiles and just use HTTP routes and stop confusing people that way.
Yep.
Yeah. We actually have two others that I'm not going to talk about because they're, I guess I can give the names anyway. We've got the mesh TLS authentication and network authentication, I think is the other one. They work with authorization policies.
Mesh TLS authentication.
Yep.
And the other one was what?
I'm looking up
Network
to make
authentication.
network authentication. I personally have never used network authentication for anything, but it exists.
Excellent.
Yeah, so that's it.
Cool.
Yeah, there's
Fun.
6. Yeah.
And we have some
So
great chat
live
happening too. Hmm.
live coding had some questions. Um,
So, so re-policy annotations. I'm troubleshooting something and see the skip inbound parts, skip outbound parts annotations. Do those annotations entirely bypass Linkerd's MTLS?
they do. And an example of when you might, or an example of a case where I use those is I will regularly use skip inbound ports to skip the ports that are coming into the Ingress controller from the outside world, because the Ingress controller should be doing terminating TLS on its own, and having Linkerd try to mess with that when it's traffic coming from outside the mesh is kind
Uh-huh.
of pointless.
Yeah,
It
that makes a lot
it's
of sense.
usually not a big deal. I mean, often it will work without that, but yeah, that's a case where I think it makes sense to do that. We didn't really talk about Ingress controllers, and I should probably point out that uh, Linkerd is very agnostic to the Ingress controller. From Linkerd's
Mm-hmm.
perspective, Ingress controller is just another workload in the mesh.
Mm-hmm.
Uh, so I will pick on emissary Ingress because it's the one I know the best. If you're running
Mm-hmm.
emissary and Linkerd in the same cluster, you will inject emissaries pods. So you'll let them have a sidecar of their very own. And then you would use skip inbound ports to tell Linkerd, hey, don't even bother looking at the ports on which emissary is receiving traffic from the outside world.
Okay.
Um, an example of where you might use skip outbound ports is a little harder to come by. You might use it for something like, I don't know, you're trying to talk to a database server that just fundamentally doesn't get MTLS or something like that, maybe. Um,
Uh-huh.
most of the times that I see people talking about skip outbound ports, I often see people recommend it as a way to rule out, oh, skip the outbound port for a minute and see if the problem goes away, as a way to rule out whether it's something with Linkerd
Uh,
TLS that's confusing the world. I kind of rarely see people say, oh, really? You can't use the mesh? Just skip the outbound port. It'll be great, because you don't really. Yeah.
we also have Fuel Stumble makes a great point. I think it's confusing that we pick two similar words, authentication and authorization, for
Yeah.
identification, and then then we refer to both of them by auth.
Yeah. There's
It's so very
it,
tech of us.
it's so annoying. Yeah. What's even worse is that in a lot of cases, you'll see things like, oh, this is our authorization plugin. And you kind of look at it and go, there's literally no way you can distinguish between authentication and authorization in that plugin at the point that you put it in the protocol. So why are you even trying to say that it's only supposed to do one of these two jobs?
Yeah.
Yeah, things.
So there
Yeah,
was one question up top that we had that we said we'd get to. Do you remember that Retrospect gave a question? Do you remember?
I don't. Uh,
Let me
let's
see.
see.
I think it was them. I want to make sure we got to it. So,
I see conversations about Skynet.
does anyone remember? Mhm. Oh, here is the question. I was wondering
Okay.
about Istio ambient service mesh and if Linkerd had something similar. What do you think of this direction using a tunnel between clusters instead of requiring sidecars for each and every container? So I guess we did kind of talk about that.
We talked, yeah, to address that one specifically, no, Linkerd does not currently have anything like ambient. Um, I mean, never say never, but nothing's,
But we talked about
no
why.
particular intentions at this point. Yeah. What I personally think is that requiring sidecars for each and every container is dramatically operationally simpler than using
Mhm.
something. Yeah, and so I
All
I
right,
like the simplicity there.
me, I'm sold. So I am going. So the way we're going to wrap this up, I'm going to do a recap of everything you've taught us today, make sure I have clear understanding. And if anyone has questions, any last questions, please ask them now. And then after the recap, we're going to say goodbye and we'll replay the theme music and dance a little bit while we say goodbye. So get warmed up. Start doing some stretches over there.
Who did the theme music, by the way?
Oh, thanks for
Who did the
mentioning
theme
that.
music, by the way?
My brother did. And by the
Oh, cool.
way, my brother, he has a new album that came out today. So his band name is called Mutual Benefits, and you can stream it anywhere. I'm so proud of my brother. So, and it's such a good album. And so please check it
Congratulations,
out.
Whitney's brother.
Yeah, congratulations, Jordan. All
Cool.
right. Yeah.
Very cool.
So that's the Easter egg. If you made it all the way to the end of this episode, you can. I'm actually going to.
I'll have to go
There's
check it out.
some shows where some album release shows, and I'm going to sing in the band. I used to play in the band back in the day,
Oh, cool.
so I'm gonna get
Okay,
back
wait a
on
minute.
stage in a musical capacity.
What did you used to play?
I used to play keys and I'd sing harmonies with my brother. Yeah, it's a very pretty band.
Harmony.
All right. Yeah, let's get.
Wait, you can't tell us you're singing lead. Come on.
Oh, I've I've done, I've lived a life, Flynn. I've done a lot of things. We don't need to get into that. All right. So first we started with the question, what is service mesh? And we're doing this whole series on Enlightning. We're doing this whole series on service mesh, and I intend to ask every guest from every project, what is service mesh? But Flynn's answer, which I think is wonderful, is service mesh is an infrastructure layer that adds security, reliability, and observability uniformly across your entire application. So none of these three things are optional. Security, reliability, and observability are things you 100% need. So if you don't add these characteristics via a mesh, the alternative is to get these things by having the developers add them directly to an application, which results, it's not necessarily uniform how they might choose to implement that. It's also like not the way that they're excited to add business value. It's also repetitive work. So there are a lot of reasons to do that at the infrastructure, at the mesh level, and not at the application level. I have a question. Chocolate or vanilla? What do you like better, chocolate or vanilla?
Peanut
Says
butter?
Napalm.
Unless it's really good vanilla, I'm going to have to go with chocolate.
Yeah. All right. So most meshes are implemented using sidecar proxies. And we drew that here in our thing. So, in terms of service mesh land, Istio and Consul use Envoy as their sidecar proxy, and Linkerd uses a custom written proxy, and that seems like a major differentiator between the different implementations. Envoy is cool. The industry loves it, but it's also a heavier weight thing that can do everything, including Ingress type stuff. And Linkerd's like, we don't need all of that in a service mesh. That's more functionality than we need. Let's write a custom proxy that is a lighter weight thing that's just for service mesh. So Linkerd only uses about 10% of the resources that Envoy does, the Linkerd proxy. And it's designed from the ground up to be a mesh proxy.
I'd also point out that doing it in Rust is a significant difference between Envoy being written in C++. There's a class of problems that Rust sidesteps entirely that C++ can be really badly burned by.
Oh, so Rust is part of what aids in the simplicity of it.
Yeah.
Cool. And then we said most meshes are implemented using sidecar proxies because we have projects like Cilium and Istio Ambient trying to avoid putting a proxy with every pod. I know Cilium at least is doing that on the kernel level using eBPF. Is that what Istio Ambient is also doing?
You should really ask Marino about that.
Okay, I will. Cool.
I don't think they, I don't really know actually.
Okay.
But the important thing about Cilium, I think, is that they do use eBPF. They don't talk a lot about the proxy, but there's still a proxy involved. So,
yes. Yeah. There's still proxies involved. And you did say that it's good for layer 4 for TCP and UDP. But
eBPF is great at layer 4.
Yeah, but not as great for layer 7, which I never wrote down is HTTPS. So then we drew out Linkerd. So Linkerd, I guess So Linkerd, we drew out a couple of pods, and then each pod has its own sidecar, which is the Linkerd mesh proxy.
Mhm.
And then those sidecars are what talk to each other. And then there's also a control plane for the service mesh. And at first we drew it generically, so it's not even specific to Linkerd, but this is the setup of any sidecar-based service mesh. But then
Right.
we got into Linkerd specifically. So this for Linkerd, the mesh control plane has 4 components and a 5th bonus component that we'll talk about later. I have a proxy injector, an identity controller, a destination controller, and a policy controller. So the way it works in a linear fashion is that the proxy injector, believe it or not, injects a proxy
I
into
know.
your.
Shocking.
You heard it here first.
Yeah. Yeah.
Injects a proxy into. So when a pod's getting made, like a regular application pod, it's injecting an extra container next to the application container that adds the mesh proxy, and then starts that proxy running. Then once that proxy is running, it's going to reach out to the identity controller to get its certificates. And then once requests start coming in, per request, it's going to reach out to the policy controller and the destination controller to see what to do.
Right.
So to spell out a little bit more what each thing does, the proxy injector modifies the definition file of the pod to add the proxy, and it also gives boilerplate configuration to the proxy. The identity controller is itself a CA, a certificate authority is what CA stands for. And so
Certifying
it's
authority.
what is
Certifying
it?
authority.
A certifying authority. Okay. It verifies the proxy CSR, which is a certificate signing request. It verifies that plus the service account token. And if everything's in order, then it issues a certificate. The identity controller does. So one thing you wanted to point out about Linkerd specifically is that there's no workload identity based on network with Linkerd.
Yep.
So then the policy controller and destination controller, you kind of wrapped into one thing. So those work together to figure out to whom a proxy should talk to, and then whether they're allowed to talk to them based on the certificates and stuff that have already been issued. So it's solving the problem of needing a way to get traffic from the cluster IP, the cluster IP to the proxy, and whether it's allowed. And then I'm still going to leave the bonus one out. So basically, the mesh control plane, what it does is it manages the proxies, but it also is centralizing all the metrics collection. So in terms of that observability element, which we didn't talk a ton about, but the mesh control plane's doing that too. We also talked about why we might want to use sidecars over this way of doing it, which is probably eBPF based. And one is it's operationally simple. And so it's one-to-one with a pod. And so if you understand how pods work, you understand how this works. Like in any operations you would do with pods, you just also do with your mesh. And it also, even the Envoy implementation of it is a heavier weight implementation, but it can be a lightweight, as evidenced by Linkerd's implementation. And then the security profile of the sidecar matches exactly the security profile of the application that's also running in. So, or the pod in its entirety, however you want to look at that. So that way it has the least privilege access. You're never giving anything more access than what it needs.
Right.
And so then we talked about how the certifications work. So with it, so Service Mesh will help you have secure communications from all within your cluster. So MTLS all around, everything talking to everything is secured with MTLS. So that happens with, so we have our workloads communicating with each other. Our workloads have their own certificates. But then we already said what issues those certificates is the identity controller issues the certificates to the workloads. But there's also a trust anchor certificate that's not in the cluster, and that's what's giving the certificate to the identity controller.
Right.
And you're meant to keep this outside of the cluster. And so now we can use this trust anchor certificate if we make a second cluster and use Linkerd in that cluster, and we use the same trust anchor certificates, then we can now these clusters automatically work pretty well together, depending on which version of Linkerd. You might have to do more or less. So at the very least, we need the same trust anchor certificates. And then if we want to do a Linkerd multi-cluster, then we have a gateway service and then a proxy pod that's associated with that gateway service. So to talk about one-way communication, the pod in this other cluster can now talk to the proxy pod that's associated with the gateway service, which can then talk to the workload pod in this cluster.
Right.
And but with Linkerd 2.14, if your network supports
Or
direct pod
2.14.
Yes. Yeah, if your network supports,
was a long time ago.
Yes, my bad. If your network supports direct pod-to-pod communication between clusters, then the gateway part is no longer needed. It can all act like one big Linkerd cluster, and it just works. It automatically works. So again, anytime we do multi-cluster, that trust anchor cert, like regardless of whether the gateway is used, that has to be part of it. Linkerd will handle all for you, rotating your workload certificates, but then you need to worry about rotating your identity controller certificates and your trust anchor certificates. Yep. Almost certainly you'll do that with Cert Manager, which makes it an easy breezy, beautiful. Yep. And then now we get into that bonus, the bonus control plane components, which is the service mirror. So that's a way to control which services from one cluster are available in another cluster. So you don't want to automatically assume the whole cluster should be available to each other. And presumably, if you wanted the communication to go two ways, this would also get its own gateway service, and then it would be handling things that come in.
Yep.
Great. Exactly. And then finally, we talked about all the Linkerd CRDs, which we named a lot of them. We have a server, which is like a Kubernetes service, but more granular. We have a service profile, which is a way to define characteristics of a workload. We have authorization policy, which describes what's authorized. We have HTTP route, which is a gateway API
CRD
resource. Yep. Yes. And so eventually service profile will be deprecated in favor of this HTTP route so that it complies with gateway API. But
yeah, I should probably point out we don't have a timeline for that deprecation. So for the foreseeable future, they'll both be around. But it is definitely a thing that we're looking at. You know, we don't really want to keep teaching people about two different ways to do the same sort of thing.
Absolutely. And gateway API is the future. And then there's other ones we didn't say what they do: mesh TLS authorization and network authentication, excuse me, and network authentication.
Right. And they work with authorization policies.
Excellent.
Yeah.
Yeah, that makes sense.
Yep.
And that's everything. That's Linkerd in a nutshell, all crammed into one lightboard. How do you feel? Is there anything you'd like to add, or any part of the story you didn't feel like we told really well?
I think the only thing I would add, we commented early on that actually, I guess there are two things that we can mention kind of in passing. They don't really they don't really correct anything. They're just adding a little bit of nuance. One of them is that we talked about the control plane centralizing metrics collection. I think I said this earlier, but just to reiterate, the metrics are under the hood handled by a Prometheus that scrapes them straight from the proxies.
Mm-hmm.
And then that permits you, of course, to use things like Grafana if you want to do visualization. There's also a Linkerd extension called Linkerd Viz, which can do some visualization of metrics. But anything that can work with Prometheus will work with Linkerd stuff.
Love it.
And the other thing I was going to mention is Linkerd does have an extension mechanism that can sometimes end up looking like it's adding extra bonus things into the control plane. We didn't really talk about that much because it doesn't really change anything about what we're talking about here. But for example, there's an older extension called Linkerd SMI that lets you use service mesh interface resources, at least a couple of them. But like SMI, the SMI extensions you should probably be using Gateway API instead at this point, things like that.
Okay. So there
Yeah.
are extensions, but maybe the problems that extensions solved have been solved already in other ways.
Well, so for example, multi-cluster is technically an extension because
Okay.
not everybody wants to use multi-cluster, and so we don't make you install it, right?
Okay.
But so there are a couple of things like Linkerd Viz, the visualization thing, is also technically an extension, and that one we tell people, probably they do want to install that one unless they've got their very own metrics thing out there.
Cool.
But in a lot of ways, trying to get into that level of detail just complicates the world without really helping explain what it's all about. So,
which goes against what Linkerd is the whole point is to keep it a simple way to implement service mesh. This has been an absolute joy, Flynn. Thank you so much for your time and your expertise.
One thing that occurred to me to wonder after we'd already talked about it, have you done an Enlightning on TLS and MTLS?
No, we talked a lot about PKI infrastructure as part of the cert manager episode, but I haven't done one on MTLS. You recommend it? Yeah.
I would be curious to hear if people thought it had been adequately covered or if it's still horribly confusing to lots of folks.
Probably both. They don't sound mutually exclusive.
I first ran into certificate management and TLS and all that in, I want to say 1999, maybe 2000. I don't think it's gotten appreciably better since then. So Avo says, I'm sorry, is it Avo or Avo? I would love to know how to pronounce that. MTLS is cool and needs more coverage.
In favor of an MTLS episode, sounds like.
Yeah, it's ignorance isn't bliss, it's dangerous. Who said that? I got that from a newspaper. I think I got that from For Better or For Worse decades ago. Well, yeah, maybe we'll talk about that later sometime. It probably wouldn't take 2 hours. So
I hope we do find an excuse to work together again soon.
Yeah, likewise.
It's been an absolute blast. Thank you, everyone who's here. Thank you for the wonderful, lively chat today. All of your great questions.
Thanks very much.
Thank you, Flynn, for sharing your time and your expertise. And I appreciate
Thanks for having
everyone.
me.
Yeah,
it's been a lot of
music.
Fun.
Yeah, good. I'm happy you're happy. All right. Bye. Come on. Let's see your moves, Flynn. Yeah, there it is.
What is that? Oh, that's a waving person. Yeah.
All right. Bye, y'all.
Have a good one. Nice to see everybody.